Mm. So, hello everyone. Uh, Welcome back to today's live interactive session on geology and soil mechanics. Myself, I am Ashish Chaudhary. I am a research scholar at IIT Kanpur, and throughout this course, as you know, I will be taking 2 hours of discussion sessions every week uh, for the rest of the duration of for the whole duration of the course. So. Uh, I hope all of you have got the link to the YouTube channel. Everything was shared to you from NPTEL. So all these lectures, all these videos, all the videos for the interactive sessions will be uploaded there. And also along with also we have been provided with the link to the PowerPoint presentations. So you can refer to that anytime, whenever you want, whenever you have any doubt. Uh, so it will be helpful to you. So the main topic of today's discussion is from our week 2 lecture, which was taught to you. That is on soil classification. So mainly we will be dealing with soil classification, and then we will be looking a little bit into the uh, how, like, what forms a soil, like what are the constituents that form a soil. Okay, so let us start. So during the discussion, if you have any doubt, please feel free to interrupt me anytime and ask me anything if you want. Also, uh, also please be attentive throughout the lecture, so it will be helpful to you in the long run. So the first the first thing which we learned was, what are the objectives of soil classification? So what is soil classification actually? So soil classification is nothing but to group soils which show same kind of behavior. So there are innumerable types of soil that are present around us or around us. The main objective of soil classification is to group them. So if we group them, uh, that means a particular group will have same type of behavior. That is, they will show same type of engineering property. So So as soon as you get to know about a soil, that a certain soil belongs to this category, you would be able to guess, you would be able to make a very good guess about the probable engineering properties of that soil, or the how the soil is going to behave when such a load acts on it. Okay. So this is the main objective of soil classification. That is to group soils which show similar behavior, and also soil classification provides us with information about the probable engineering behavior of soil. Okay. Now, there are different soil classification systems available. The main, like the principal three important classification systems are the Unified Soil Classification System, that is known called as the USCS system. The next is the American Association of State Highway and Transport Official System, that is the ASTRO system. And the third is our Indian Standard Soil Classification System. So, among these, the soil classification system that bothers us is our ISSCA system. So we will be only focusing into this. Okay. So as we all know, the IS code, it is the Indian standard which defines the soil classification system, which which gives us all the rules and how to name the different types of soil, how to name the different types of soil, how to classify them, is given by IS 1498 1970. So this IS code gives us our classification system. So this is very important. Okay. Uh, I suggest all of you to have a copy of this, uh, or buy one copy of this classification system, this IS code, because you will be needing to refer it like throughout your career as a geotechnical engineer. Okay. Uh, so generally what we do is, generally as a geotechnical engineer, the first task is to, whenever we go to a site, we have a particular site allocated to us. So the first task is to classify the soil. Okay. So the first job as a geotechnical engineer is to, the basic task is to classify the soil. So in order to classify the soil, main thing we need to do is uh, main thing we have to do is determine its index properties. Okay. Some of the index properties are required, which are necessary to classify soil. We learned in the previous week that index properties are needed to classify a soil, right? So we need some index properties with the help of which we need to classify soils. So as an engineer, our first task is to classify the soil, and in order to classify the soil, we need to determine its index properties. Okay. Now, this table which you see here, this table gives us the types of different soil and the symbol, okay, the symbol or the short form by which we define it in our class during our classification. Okay, so our classification has two two components. One is our prefix, other is our suffix. Okay, so the prefixes are given here and the suffixes are given here. For gravel, it is nothing but G. For sand, if the soil is sand, we write it as S. If it is silt, we write it as M. If it is clay, we write it as C. If it is organic soil, we write it as O. And if it is peat, we write it as PT. Okay. Now, if our soil is well graded, we write it as W. If it is poorly graded, we write it as P. If it is silty, it will be M. Okay. If it is clay, it will be C. And for clay soils, one important index property which you learned is that liquid limit. So if the liquid limit is less than 35% for a particular kind of clay, it is low plastic clay. Okay, so it L. If it is between 35 to 50, it's intermediate, so I. And if it is greater than, liquid limit is greater than 50%, it is high, so H. Okay, I hope this is clear. Now, for gravel and sand, let us see what are some of the possible classification symbols formed using those prefixes and those suffixes which we learned just now here are available. So if it's GW, that means G means gravel, W means well graded. Okay, so it's well graded gravel. GP, similarly, it means poorly graded gravel. GM, it means silty gravel. GC means clay gravel. SW means well graded sand. SP means poorly graded sand. SM is silty sand, and SC is clay sand. So these are the possible arrangements of our prefixes and suffixes that you will be needing to classify coarse grained soil, that is our gravel and sand. Okay, I hope this is clear. Uh, yeah, so yeah, let us next. Yeah. Now for clay and silt, these are the probable possible symbols, which is ML. ML means inorganic silt with liquid limit less than 35%. There is CL, which is inorganic clay with liquid limit less than 35%. Other one is organic soil with liquid limit less than 35%. Other one is inorganic silt with liquid limit greater than 50%. Your inorganic clay with liquid limit 50%, greater than 50%. Then organic soil with liquid limit 50%. At the end, we have peat. Okay. Now, this particular table is available in your IS 1498 1970. So I have taken it from there. Here, all the types of soils are defined. Okay. So first we have the coarse grain component, and then we have the fine grain components. Okay. So coarse grain component, okay, is of four types. One is boulder, cobble, gravel, and the fourth one is sand. Correct. For boulder and cobble, there is no symbol. Okay. There is no symbol. So what are boulders? Boulders have average diameter more than 300 mm. More than 300 mm. Okay. Then what is cobble? Cobbles are cobbles are rounded to angular soil components. Those have sizes lower than 300 mm, but sorry, yeah, smaller than 300 mm, but bigger than 80 mm. Okay, so it's written here average diameter smaller than 300 mm, but retained on 80 mm ISC. That means bigger than 80 mm diameter size. Okay. Next, we have a gravel fraction. Gravel fractions are the fraction passing through 80 mm sieve but retained on 4.75 mm sieve. Okay. Again, the gravel fraction is classified into two types. That is my coarse and fine. So for coarse, it's between 80 mm to 20 mm size, and for fine, it's 20 mm to 4.7 size. And again, we have sand. Sand is nothing but the fraction passing through 4.75 mm, but retained on 75 micron C. Okay. So coarse, so sand is again classified into three types, C subgroup, the three subgroups, coarse, medium, and fine. We can see this, see the size distribution here. I am not repeating it. Okay. Then we have fine grain components. So fine grain components are uh, clay, silt, and organic matter. Okay. So silt are particles which are, these are also clay and silt. Both are particles that are that have size lower than 75 micron. Okay. But the main distinguishing feature of silt is that they are mostly non-plastic. Means they do not have plasticity. So if it's given in the question that the soil is non-plastic, you can directly, fine grained soil is non-plastic, you can directly identify it as silt. Okay. So silts are mostly non-plastic or might be slightly plastic. Okay. Mostly they are non-plastic, but they might be slightly plastic. Okay. Then we have clays. Clays are also fraction that are smaller than 75 micron. Okay. And they have some plastic behavior. Okay. They will be plastic. That means the plasticity index will be higher than that of silt. Okay. Now, then we have organic matter. Organic matters are also fine grained components, but the main thing that distinguishes organic matter is their color and smell, because it's made up of organic component like trees, they get decomposed, they get, so like this organic soils are formed. So organic soils are mostly black in color, blackish in color, very black. Okay, black, dark colored, and also they have a smell, distinct smell. Okay, so this was all about the types of soil, main broad types of soil. Now, when fine fraction in a coarse soil, that is, fine fraction means whenever you are You hear the term fine fraction, it should come to your mind that it means the soil fraction passing through 75 micron sieve. Okay, the soil fraction passing through 75 micron sieve is your fine fraction. Okay, now when fine fraction in a coarse soil, okay, in a coarse soil means the soil is predominantly sand or gravel. Okay, in a sand or gravelly soil, if the fine fraction is uh, less than percentage of fine fraction is less than 5%, okay, then we will classify it on the basis of grain and gradation. That means we will be classifying it on the basis of, first it will be gravel or sand, G or S, and the second part will be well graded or poorly graded. That is our gradation part. Okay, so if the fine fraction is less than 5%, it can be SP, okay, poorly graded sand, or SW, well graded sand. Similarly, GP or GW. Okay. Now, if the soil is if our soil is predominantly fine, okay, if our soil is predominantly fine, then the soil will be classified using the plasticity chart. Okay, so this is our plasticity chart, which I have taken from IS 1498 1970, published by the Bureau of Indian Standards. So if our soil is predominantly fine grain, then we have to take the help of this chart in order to classify it. So let us look into this chart. So in the x-axis, we have the liquid limit. Okay, we have the liquid limit. The y-axis, we have the plasticity index. Okay, there is a line. This line is called the A line. Okay, this is called the A line. And also remember the equation of this line. Okay, equation of this line is IP, that is plasticity index. Plasticity index equal to 0.70 liquid limit minus 20. Okay, okay, this is in percent. Okay, so this is the equation of this line. So in this chart you can see all the divisions. Okay, so this is our 35% liquid limit line, this is our 50% liquid limit line. Okay, so this side it will be, it is L, in between it is intermediate, and this side it is H. Okay, if our fine soil falls below this chart, below this line, below this A line, then it is MH or OH. It is sealed, or it might be H or I or L, whatever it is. If it is below the A line, okay, if our fine grained soil is below the A line, it is either silt or organic soil. Okay, it is silt or organic clay, either of these. Okay, and if it is above the A line, okay, if it is above the A line, then it is clay. Okay, if it is below, it is silt or organic, and if it is above, it is inorganic clay. Okay, this clay. And also, if our soil falls in this hatched portion, okay, this hatched portion you can see. If our soil falls in this hatched portion, then we use a dual classification as CLMN. Okay, so this is the dual classification if our soil falls in this hatched portion. Okay, so we will be needing this plasticity chart at every step of classification of a soil. Now, when the fine fraction in a coarse soil is greater than 12%, okay, before our case was less than 5%. The case which we studied was less than 5%. Okay, now if the fine fraction is greater than 12%, if the fine fraction is greater than 12%, then it is then our coarse soil will be classified as given here. It will be either GMSM or GCSC. Correct? If it plots below the A line, then it will be GM or SM. And if it crosses above the A line, it will be GC or SC. So coarse soil, okay. We are talking about coarse soil. It will be either means it will be either G or S. Correct. It is either G gravel or either sand. Before what we spoke about is it is GWGP or SWS. Okay. Now in this case, if our fine fraction is greater than 12% in a coarse soil, then it will be either GM. Our suffixes are going to change. It will be GM GC or sorry SM SC. Okay. If there is considerable amount of fine fraction in our coarse soil. Okay. Okay. This is the condition. Now we come to the third case, which is what if our fine fraction is between 5% and 12%? Okay. If our fine fraction is between 5% and 12%, we need to go for dual classification. Okay. So if the fine fraction in our coarse soil, if the fine fraction is between 5 and 12%, then we need to go for dual classification. So I've given one example here, which is well-graded soil, well-graded sand and clayey sand. So both we have to use because our soil has considerable amount of fines. It is between 5 and 12%. If our soil would have less than 5% fines, then this part would have been not there. Okay, this part. Okay, only this part would have been there. And if our soil would have been having fines greater than 12%, then this part would have been not there. Okay, only this part. As the fine content is between 5 and 12%, we are somewhat in between. So we need to use dual classification. Now I ask you a question. Can fine grained soils have dual symbol? Okay. Now we spoke about our coarse soils. Okay. Till now, the main predominant soil was coarse soil. Now I ask you, can fine grained soils have dual symbol? Okay. Can we have dual symbols? Anyone, if you can answer?
If it's close to a line,
Yeah.
then
And
between 35 and 50.
35 and 50. Okay. So actually, see, you're correct, partially correct. So one more thing is we already studied one thing in the previous slide. One thing is if our soil is in between hashed portion, if it's between the hashed portion, we are using dual classification for our fine grained soil. It is CLML. Okay, we are using. Now let us see the other cases. Okay. Okay. Now yeah. So let me go to the A line. Yeah. So as you told that if our soil, yeah, if our soil is very close to the A line, okay, it's very close to the A line here or here. Okay, these are the points. If these are the points, then our fine grained soil has to be doubly classified. Okay, there has to be 12 symbols. Okay, so whatever you said is 100% correct. The second thing which you said, that is also true. That is when our soil is very near to this line or this line. Okay. Okay. Our soil is here or here. Then also we need to go for dual classification. These were the two things. The third is this one, CLML. Okay. These are the three cases in which our fine grained soils are going to have dual classification. So generally it doesn't happen. Most of the cases we will see that either it's CLML or we are going to have one single classification only for soil. Okay, now these are the possible dual symbols. The first one is our CLML. Okay. Then you told that it's near to 35%, that particle line. So it will be this one, sorry, not 35%, it will be near to the A line, but between this, okay, 35 to 50, and here in this region, it will be very close, then it's this one. If it's here, if it's here, then it's this one, CHMH, okay. And this one, if it's below the A line, okay, if it's below the A line, but here, very close to here, then it will be this one, MLMI. When it's MIMH, that means it's here, okay. Then CLCI, okay. Similarly, if it's here, then it's CLCI, then here, then CICH, okay. Similarly, for also for organic soils, okay. Now, the main thing, how are you going to classify the soil? So let us see stepwise, how are you going to classify the soil? Okay, so the first step is going to be, we need to obtain the grain size distribution graph. So we learned how to obtain the grain size distribution in the first week, a distribution plot. So the first task is going to be to obtain the grain size distribution curve from the sieve analysis. Okay, sieve analysis. It may be only dry sieve analysis, it may be wet sieve analysis, both, or it may be dry sieve, wet sieve, and along with our this one hydrometer analysis. So complete grain size distribution chart, grain size distribution graph, you have to plot starting from 80 mm to below 75 microns, whatever possible. After the hydrometer analysis, you need to conduct your sieve analysis along with the hydrometer analysis and plot your grain size distribution curve. Okay. Now, if more than 50% is retained on 75 micron, that means our soil is coarse. Okay. Okay. If more than 50% retained on 75 micron sieve, that means coarse. Correct. First thing, as soon as you see that more than 50% is retained on 75 micron, you can say that our soil is coarse. Correct. Now, second thing that should come to your mind is, what kind of coarse soil? Is it sand or is it gravel? Again, to know this, how can we know this? If more than 50% is retained on your 4.75 mm sieve, then if greater than 50% retained on 4.75 mm sieve, then it is gravel. Okay. And if more than 50% passes 4.75 mm sieve, then it is sand. So below 4.75 mm, it's our sand. We know that. So if more than 50% passes through our 4.75 mm sieve, that means it is sand. Okay. And if more than 50% is retained on 4.75 mm, it is gravel. Okay. Now this is over. Now you know that it is coarse. Now also you know that it's either G or it is S. Okay, either it is gravel or it is sand. Now we need to look into the fine fraction. Now, if fine fraction greater than 5%, sorry, less than 5%, if the fine fraction means the fraction passing through 75 micron sieve in our soil is less than 5%, then the thing that should strike your mind is that the suffix will be either well graded or poorly graded. It will be either W or P. Correct? Okay. So you need to determine W or P. What you need to do is you need to determine the D10, D60, D30 sizes from your grain size distribution analysis graph. Okay, grain size distribution graph, and then you need to determine your coefficient of uniformity and coefficient of curvature. Okay, after determining coefficient of curvature and coefficient of uniformity, if it falls in your in your range, the range which is already given, CC should be between 1 and 3, I guess, and for sands, CU should be greater than 6, and for gravels, it should be greater than 4. Okay, if your CU, CC fall within the range, then you can call your coarse fraction as well graded, else it will be poorly graded. Okay, done. Uh, now next is, if our fine fraction is greater than 12%, if the fine fraction is greater than 12%, then what will be your suffix? It will be either clayey or silty, C or M. So to know C or M, what you need to do now is that you need to do the liquid limit and plastic limit test on the soil. Okay. After doing the liquid limit and plastic limit test, what you will get to know is the liquid limit and the plastic limit. And then from there also you can know the plasticity index. After knowing this, you can plot, you can see where the point flows in your plasticity chart. If it's below the A line, it will be M. If it's above the A line, it will be C. So like this, you can find out the suffix of your nomenclature. Okay, it will be either SC, SM or GC, GM. Correct. Now again, this already we discussed. If it's between 5 to 12%, 5 to 12%, you need to do both. You need to determine your coefficient of curvature and coefficient of uniformity. Also, you need to determine your plasticity index and liquid limit, and from there, you will know it is C or M. And from the coefficient CU and CC, like the coefficient of uniformity and coefficient of curvature, you will know it's well graded or poor graded. Okay, so here it will be dual classification. Done. So now next is for fine. Okay, up to this much our course is over. Coarse soil is over. Now for uh, fine grained soil, and if it's inorganic, okay, remember, not we are not talking about organic. Okay, for fine grained soil means if the soil fraction more than 50% is passing at 75 micron sieve, then it's predominantly fine soil. Okay, so you directly know your prefix now. It will be either clay or M. Okay, okay. If 50% is passing to 75 micron, you know that it will be either clay or silt. Okay. Now, what we need to do is, so our prefixes are determined to us. Then what we need to do is, we need to determine our plasticity index and liquid limit. Okay. So what we do is that we take a certain amount of soil that is passing through 425 micron sieve. Okay, some amount of soil, and in that 425 passing soil, we do the liquid limit and plastic limit experiment to determine our plasticity index and our liquid limit. I already discussed about the liquid limit and plastic limit test in the week 1 lecture. So we need to take the soil fraction passing through 425 micron sieve and do the liquid limit and plastic limit test on that soil. Okay. Now you know the plasticity index and you know the liquid limit. So you have your A line. Okay. Now if it falls below A line, it will be M. Okay. It will be silt. And if it falls above the A line, it will be clay. Okay. And one more thing you have to remember is your hashed portion. If it falls in the hashed portion, it will be dual classification CLML or the other two cases which we already discussed in the previous slide. Okay. You also always keep this in mind. Okay. So for fine, it's very simple. You take if more than 50% is passing to 75 microns, it's fine. It's definitely either clay or definitely it's silt. If then you need to find out the index properties such as the liquid limit and the plastic limit and the plasticity index. So if it plots below the A line, it's our silt. If it plots above the A line, it's our clay. Okay. Now, if our soil is for same, if we know that if our soil is of organic origin, means if our soil has a dark color, if it smell some kind of distinct smell, and you know that your soil should be some there should be some organic content, like it's organic soil. You know from this from your observation. And then if it plots below the A line, and then if it plots below the A line, it will be O. O, that is our organic soil. In place of M, it will be O. Okay. So C or M directly you can say from this thing. You can directly say it's C or M. Then you determine this. Okay. Then from there you see where it's plotting. If it's above, it will be C. Definitely it's C. If it's below, it will be M or O. Then you already know the liquid limit of the soil. Then if it's if it's this side, it will be low, CL. If it's CR, it will be CI. And if it's greater than 50%, it will be CH. Okay. Okay. Yeah. Now, the critical case, okay, this is the critical case. So generally, 99%, 99.59% chances are that you won't encounter this kind of soil in your career, but still there might be something this. So chances are very, very less. Okay. Exactly 50% if it's fine. Okay. If exactly 50%, okay, exactly 50% is less than 75 micron, and exactly 50% is greater than 75 micron. Okay. Then what we need to do is, this is a like theoretically possible case, but practically it's hardly possible. Okay. It's like almost impossible practically. Like 50% fine content and 50% your this 50% coarse content. Then what we need to do is that we need to find out the liquid limit, and then classify it as low, intermediate or high. Okay. Li or H, below 35% L, between 35 50 I, greater than 50 H. And then you assign your dual symbols. Okay. Dual symbols like GMML. So, that is uh, silty gravel, and also low plastic silt. Okay. Like this. So this is very, very theoretically possible case, but almost impossible in practical life. So this was our last case. Okay. So this ends the main classification part. Okay. Up to this, it was the classification part, how we classify the soils. First, let me just summarize very fast, very rapidly, whatever we studied. So first we studied was what are the different first we studied why we classify soils. Okay. First we studied why we classify the soils, that is to group them. Okay. So group them and provide us information of the probable engineering behavior. Okay. Then we learned about the different soil classification systems. Okay. Then we saw this one, our Indian classification system, what are the prefixes and what are the suffixes that we use. Then we saw some probable nomenclature for for coarse soils, that is gravel and sand, and also similarly for our fine soil, that is clay and silt. Then we defined the different types of soil available here. Okay, as per the Indian standards. Then we came to know about this plasticity chart. Okay, and how to classify a soil based on the plasticity chart. Okay, okay. Then we learned about the dual classification of both fine grained soils and coarse grained soil, and then we learned about the steps for classification. Okay, so just a minute. Yeah. Now the second part of this discussion is soil structure and clay mineralogy. Okay, so What is soil structure? Soil structure is nothing but the arrangement of soil particles. So soil is formed of particles, right? Okay, so if you zoom zoom a particular amount of soil, you take in the hand and zoom with the help of a microscope, you will see that the soil particles are arranged in a particular fashion. Okay, so what is the soil structure? The soil structure is the arrangement of those particles plus the forces holding those particles. Okay, so both together we call the soil structure. Okay, the soil structure, one part is the arrangement and the other part is the forces that hold those particles together. Okay, this forms the soil structure. Now, coarse grained soil, what is the main force that holds them together? Because it is coarse, because the particle size is high, it's big. So the main force that is coming into play here, that is our force of gravity. Okay, so gravity is the force that holds the particles together in case of coarse grained soil. Okay, and for and for clay soil, that is clay or soil, that is fine grained soil. Fine grained soil, there are certain surface bonding forces. Okay, there are some different kinds of forces, bonding forces like the hydrogen bond or van der Waals force. There are different kinds of surface bonding forces which bind these particles are very minute, okay, very small. Okay, this, as they are very small, there are other there comes the play of another type of force which is different from gravitational force. Those are called the surface bonding forces. Okay, those surface bonding forces are predominant in fine grained soil. Okay, then what is the specific surface? The specific surface is the ratio of surface area of the material to its mass or volume. Okay, say you have 1 meter cube of sand and you have 1 meter cube of clay. Okay, so obviously the specific surface in that of each particle, if you sum everything, for the clay it will be very much high. Okay, because the particles are very small, so so the specific surface will be high. Okay, so this is the specific surface. Now specific surface determines which is dominant, either gravity or surface bonding. If it is high, it's very high, specific surface is very high, our surface bonding forces will be predominant. If specific surface area is very low, our gravity forces will be dominant. Okay, then we have, yeah, now the clay soils are fine grained soils, correct? So there our surface bonding forces are predominant. So clay soils are made up of certain clay minerals. Okay, these clay minerals have plasticity and cohesion. Okay, plasticity, already know what is plasticity. If you take a clay, you can mold it, like you can mold it in any shape. So that property is plasticity. And what is cohesion? Cohesion means the force which binds two particles. Okay, cohesive forces means similar kind of particles. And what is adhesion? Adhesion is force between dissimilar kind of particles. Okay, so cohesive forces. Okay, now clay minerals, as they are very small, they are electrochemically active. So that means there is a play of electrochemistry here. So there are the clay particles are generally charged particles. Okay, charged particles. Yeah. Now, what forms our clay minerals? So clay minerals uh, is formed from by our chemical weathering. Okay. So the rock, there is rock. There are rock minerals. Rock minerals are those constituents which form a rock. So what happens? There is weathering. There is disintegration of the rock. So the rock breakdowns into minerals, and those minerals undergo certain chemical changes. Okay. During the weathering process, those minerals undergo certain chemical changes. So when soil is formed from rock, the minerals forming the rock, they undergo certain chemical changes. Okay. So due to those chemical changes, the properties of those minerals changes and the clay minerals are formed. Okay. So we will see what are the main types of clay minerals. So the clay minerals are divided into three groups. Okay. Based on their crystalline arrangement, means the arrangement of their crystal. the clay minerals are divided into three groups. The first is our kaolin, second is montmorillonite, and the third is elite. So these are the three groups, okay, three groups which form the clay particles. Okay. Now these three minerals are again formed by two fundamental crystal sheets. It is a tetrahedral or silica sheet and octahedral or alumina sheet. So our clay is formed from kaolin, montmorillonite, or elite, Km or I, and this Km or I is in turn formed from tetrahedral sheet and octahedral sheet. Okay, so this is how a clay is formed. Clay is formed. Okay, now the stacking, nature of bonding force, and the metallic ion in the lattice differentiate them. In the stacking of this tetrahedral and octahedral sheet, the bonding forces between the sheets, okay, and the presence of some metallic ions in between the sheet in the arrangement of sheet. So in between the sheet, if certain metallic ions are present, these three things, three things form these three types of clay minerals: kaolin, montmorillonite, and elite. Okay, the arrangement. Uh, so these are the main uh, things which differentiate this K, M, and I: kaolin, montmorillonite, and elite. Okay. So first is our tetrahedral sheet or silica sheet. So what is a tetrahedral sheet? Tetrahedral sheet is nothing but it has four four oxygen atoms. Okay, and in the middle there is a silicon atom. Okay, one silicon atom. Okay, so those four oxygen atoms are from the four corners of a tetrahedron. Okay, tetrahedron is a shape, so geometrical shape. So those four oxygen atoms from the four corners of a tetrahedron, and the between there is our silica. Okay, one silica atom. This is the tetrahedral sheet. Okay, next is our octahedral sheet. In octahedral, okay, there are six hydroxyl means OH minus ions, okay, at the tip of the octahedron. Okay, there are six OH minus ions at the tip of the octahedron. Okay, and in the center, similar to this, in the center, it's either aluminium or magnesium ion. Okay, it may be either aluminium or magnesium. So if in the center we have aluminium, then it's called gypside. Sorry, gypside. And if it's magnesium, it's called brucite. Okay, it's either gypside or brucite. So these are the two constituents which form the clay minerals. Okay, different arrangements of them, different stacking, different bonding, and the presence of other metallic ions, they form the different clay minerals: kaolinite, montmorillonite, or elite. Next, we learn a term which is isomorphous substitution. Okay, so what is isomorphous substitution? So in the clay mineral lattice, so clay mineral is formed by stacking, arrangement of those sheets which you just studied here. Okay, so in the clay mineral lattice, if the metallic ions, the ions which are present, as now you saw the metallic ions, which will be silicon, magnesium, aluminum. Okay, these metallic ions are replaced by some other metallic ions which have lower valence. Okay, which is lower valence, that is lower charge, but the size is same. Okay, size is similar to the metallic ion already present there. Okay, then this process is called isomorphous substitution. Okay. Now let us see what is kaolinite. So in kaolinite, what we have is we have one gypside sheet, and below it we have a silica sheet. Okay, we have a gypside sheet and we have a silica sheet. Okay, and there is some bonding. Okay, bonding material here. Below that we have another. So this way it continues. Okay, and the height of each this one is 7.2 Armstrong. Okay, so this is our kaolinite, correct? So the main thing in kaolinite is that uh, these structural units. So these are the structural units, right? So these structural units are held together by, sorry, together by hydrogen bond. Okay, this is very the most important property. So these structural units are held together by hydrogen bonds. So as they are held together by hydrogen bonds, the bonds are very, very stable. Okay, very, very stable and very, very strong. Okay, so due to this, what happens? The clay minerals which are formed by kaolinite, they are least active. Okay, they are least active means they don't swell up or nothing happens. If you like say you pour water, submerge kaolinite clay in water, so there will be hardly any swelling of the clay. Okay, there will be hardly any swelling if our soil is kaolin. Okay, that is the kaolin is the least active because of the presence of hydrogen bond. Okay, kaolin is least active. Next we have your montmorillonite. Okay, so how is montmorillonite formed? So there is one silica sheet. Then we have one gypsite sheet, and again you have one silica sheet. Okay, this way montmorillonite. So similar, this unit gets on repeated. Okay, this unit and the height is 9.6 Armstrong. Okay, so this unit gets repeated. Similarly, here also you will have one more. Okay, so this goes on repeating. Now, the main thing here is that the bonds which are present here are very weak. Weak van der Waals bond. Okay, the bonds are very weak. So due to these weak bonds, what happens is that easily any metal or any water ions like water molecules can easily enter and occupy this space. Okay. So due to this, what happens? These soils, the clay made up of montmorillonite are extremely expansive in nature. If you submerge this soil in water, it will like expand very much. Okay, expand very, very much because they are highly active. These are very active. Because of the weak forces between the structural units, what happens? Easily some other ions or some other this exchangeable ions can easily enter in between the lattice. So due to this, what happens? They expand in size. So this is very, very problematic soil. So you might be knowing about you might hear about this black cotton soil. So in South India, if you go near Madurai, it is also in Visakhapatnam and all. So you will find this um, black cotton soil. Okay, so black cotton soil is very dangerous for construction because what happens in winter time? No winter, like when there is no rain, it's fine. Okay, you can easily construct something about it. As soon as rainfall, there is monsoon. Okay, as soon as there is rain, what happens? This soil keeps on expanding by large amount. Okay, the volume expands humongously. Due to this expansion, what happens? There are failures of the this failures of the structures built over it. So these montmorillonites form highly expansive clays. So expansive clays form a very big part of research topic like in our geotechnical engineering. So like uh, huge amount of money is like been put in the research of expansive clays because the time and like uh, many big like engineering projects have failed due to this expansive clays. Okay, so this montmorillonite is very problematic. Okay, the presence of montmorillonite means danger. You cannot construct anything. Okay, so I don't remember actually the name of the project. So there was some railway project, okay, where I forgot. So railway project in India only. I forgot the location. So what happened was that due to this black cotton soil, the railway track completely got submerged. Okay, so what the engineer suggested was that to like stabilize, either to stabilize, but the stabilization also like there are certain chemical methods. Okay, there are some certain ways where you can mix something. Okay, like lime or something you can mix to this clays, clays consisting of Mont right? So if you mix those chemicals, what happens? The expansive property gets reduced. So so what happens? So the engineer suggested is either you treat it or either you completely remove. So what happened? The railway what they did was they completely excavated the amount of like huge excavation was carried out and they completely removed the black cotton soil. They again they filled it, compacted it, and about that they uh, built the railway track. Okay, so this is very like problematic kind of soil. Okay, so because easily water can enter and it can swell, and also as the water goes, as the season becomes dry, it can easily shrink. So any construction about it will get damaged 100%. There is no option, there is no chance. So you should avoid this kind of soil, or you should know that this place has this kind of soil, so I should treat it before the construction. So see, nowadays we don't have space, right? There is space crunch everywhere. We need to construct, space is limited, we need to construct. So how can we like just leave a certain big area of land? So what we need to do is we need to treat it. So there are certain stabilization methods, ground improvement methods, which you can use, which you can study in the ground improvement techniques chapter or your course also. So there are many techniques using which we can improve this kind of soils. Okay, and then you can construct. Then after this we have elite. So elite is nothing but same as your this Montmorillonite. Same as Montmorillonite. Okay, this is silica sheet, this is gypsite sheet, then this is again silica sheet. But in between, before there was completely your van der Waals forces, now you have a substitution by potassium here. There is potassium, presence of potassium ion. Okay, so due to this, due to the presence of potassium, so the soils are more a little bit less active than montmorillonite. So it is higher, more active than kaolinite, but less active than montmorillonite. Okay, so if you arrange it, so most expansive is your or active is your montmorillonite, then is your elite, and then is your kaolinite. Okay, then we come to the topic of clay particle interaction. Okay, so there, as those particles are very minute, so there is some interaction between those clay particles. Okay, so in an aqueous environment means not when the clay particle is dry. There in aqueous means what presence of water is there. Okay, in aqueous environment, what happens? The clay particles may flocculate. Flocculate means they may come together, or they may disperse, or they may go away. Okay, if you look under the microscope, you can notice this behavior. Okay, they may either flocculate or they may disperse. Okay, so flocculation is mostly in H2 phase H2 phase conflict means this is a clay particle and this is another clay particle. So flocculation is like this. See, H2 phase. Okay, also there might be H2 edge or face to face. So mostly it is H2 phase, and dispersion is mostly face to face conflict in configuration means dispersion is mostly like this. Like okay, they might be a face to face. Okay, so when will the particles flocculate? When in an aqueous solution, if the coming nearer of two particles, the potential energy of the system reduces, then they will flocculate. And if the potential energy of the system reduces when they move away from each other, it will disperse. Okay, so this was all about this year uh, clay particle, how the clays are formed, the clay mineralogy, and the clay particle interaction. Okay, I hope this is clear. So now we will be solving some problems related to the soil classification mostly. Okay, so we will be solving some problems related to soil classification. So it will be good like if you can solve together. Okay, so it will be helpful to you also. These are very easy problems, so we can easily like do it together. So the first problem is, from the grain size distribution data given below, classify the coarse soil. Okay, classify the coarse soil. So first thing that is mentioned is that our soil is coarse soil. Okay, that means the soil is either sand or it's either sand or it is either gravel. And also some information is given in this table. Okay, so I request you to please try and solve it. So okay, it's very easy, so you can easily solve it, or at least you can like tell me what are the steps. The particle size is given and percentage final is given to us. Okay, so we need to classify the soil. So it's already mentioned in the question that it is a port soil. So first we need to tell that is it sand or is it gravel. Okay, is it sand or gravel? If
So it's
anyone can,
gravel
how is it gravel?
because in 0.40 micron, 60% finer particle are
Yeah,
passing through
are passing
33,
through
20.
60% is passing through 0.48 mm.
Yes, sir.
What is the size of gravel?
Mm.
What is the size of gravel? Gravel is from 80 mm to 4.75 mm, right?
Okay.
Right. So 60% is passing through 0.48 mm. Means obviously more than 50% is passing through your 4.75 mm. Right. So
Right.
Yes,
right.
sir. Yes, sir.
Yeah. So
Finer.
it will be sand.
Sand.
So first part, got to know that it is sand. Done. Now, now we need to tell that whether it's a well graded soil. See, nothing is mentioned about the fine, like we don't have data here, right? So let us assume that less than 5% is uh, finer than 75 microns. Okay, okay, let us assume this, that less than 5% is uh, passing through 75 microns. Okay, so first we identified that this is sand. Now we need to tell whether it's well graded or poorly graded. Okay, okay, now you need to answer the second part, if it's well graded soil or poorly graded soil. So please tell me what we need to find out. We need to find out two parameters, right? So what are those two parameters? To call the soil well graded or poorly graded, what are the two parameters? Yeah, Vasudevan and please can answer.
So, well graded.
Well graded or poorly graded, you need to tell. Okay, so how can you tell? You need to determine certain parameters. Okay, so what are those two parameters that you need to find out? Think, if you have the book, you can open the book and also see anything. At least you should know. That's the main point. Anyone can answer. Vaibhav, if you know. How to know that the soil is well graded or poorly graded?
Percentage finer than 5 to 12% we will have to decide.
No, 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 no. I am asking you whether it is well graded or poorly graded. Using these data, you need to tell whether your sand is well graded or poorly graded. Okay. How can you call that well graded or poorly graded? 5 to 12%, nothing is coming into the picture here. C. To call it well graded or poorly graded for coarse soil, what we need to do? We need to determine the coefficient of uniformity and coefficient of curvature.
Curvature.
Isn't it?
Yes, I forgot.
Yeah. We need to find out the coefficient of uniformity and coefficient of curvature. Okay. So to determine the coefficient of uniformity, what do we need? We need D60 and D10 size. And to determine the coefficient of curvature, you need the D30 and D60 and D10. Right? So what is our D60 size? If anyone can tell me, what is the D60 size?
D60 is 0.48.
Yeah, D60 is 0.48. What is D10?
0.21.
0.21. So what is our coefficient of uniformity? It will be 2.28. Okay. Now let us find out our CC. So what is our D30? It's 0.33.
3,
D60 is 0.48 and
48,
D10 is 0.21.
0.21.
So it is 1.08. Now, please recall what were the conditions for which it is a well graded soil. The first condition is that our Cu for sand should be greater than 6. If our Cu is greater than 6, our soil is well graded soil. Okay. And if our Cc is between 1 and 3, then it is our well graded. So both these conditions should be satisfied. Only then we can call it is a well graded sand. Okay. So we got Cu as 2.28. Is it greater than 6? No, right? Our Cc is coming between 1 and 3. One condition is satisfied here. But our Cu is not greater than 6. This is not greater than 6. Okay. So directly from this, we can say that our soil is poorly graded. Okay. So what will be the classification? What will be the classification of the soil? Please tell. What will be the soil?
Poorly graded sand.
Yeah, that means SP, right?
SP. Yes.
Yeah. So this is our answer. So our soil is poorly graded sand. Okay. So now let us go to the next problem. So the next problem, it is given that from the sieve analysis data, classify the soil. Okay. So this data is given. So sieve size is given and percentage finer is given. Okay. So by looking at this data, please tell me what kind of soil it is. Is it fine soil or is it coarse soil? First of all, tell me this. It is fine or it is coarse? It is a fine soil or it is a coarse soil?
Fine sand.
How fine sand? How fine what? Fine soil. I'm asking you fine. It is fine soil or coarse soil?
Fine soil.
How fine soil?
More than 80% passing through 4.75.
More than 50% should pass through 75 micron. Only then it is fine soil, right?
Sir, this is coarse soil.
Yeah, it is coarse soil. What?
Yes.
Yeah, it
Yes.
is coarse soil because
Please,
yeah, because
7% only passing through. That's
yeah, exactly. Only 7% is passing through your 75 micron seed, right? So
Right.
and more than 50% is passing through 4.7. It is coarse soil. And what kind of coarse soil? It is sand, right? So it is sand. Now, one more thing, if you see that what is the fraction of fine particle? What is the amount of fine particle in your soil? 7%, right? In our soil, 7% is the amount of fine particles.
Yes, sir.
Correct? So 7. So what is the 7%? 7% is between your 5% and 12%.
Yes.
Correct.
I
So if you
do.
recall, if it's between five, if the fine fraction is between 5% and 7%, we need to go for dual classification. Right. We need to go for dual classification. So it will be either SW, SM, SW, SC, SPSM, or SPSC. Correct? It can be either of these four options. The first, just by looking at the table, we knew that this is sand. Okay. Then we knew that the fine fraction is between 5 to 12%, that is 7%. So our soil is soil will follow dual classification. This is the second hint that you got. Correct. Now the third thing, if you look into the question, you can see that the soil is non-plastic. The fine fraction is non-plastic. Okay, the fine fraction is non-plastic. So if the fine fraction is non-plastic, what is it? Is it clay or is it silt? Please tell me. It will be clay or
Silt.
correct,
Silt.
exactly. It will be silt. So we got another third hint that will be silt. Okay, so we got the third hint here that it is silt. The first hint was sand, second hint was dual classification, third hint was the fine fraction is silt. Correct? So the second part you already have determined. So this from this part you have already determined that the second part will be SM, right? Right? This part you
Yes.
already have determined, correct? So now you need to tell the coarse fraction. It is the sand is well graded or poorly graded. Correct? So again, I will ask you to what are the parameters needed to tell that the soil is well graded or poorly graded?
We have to find out CU and CC.
Exactly. You need to find out CU and CC. So in order to determine CU and CC, we need to find out the D10, D30, and D60 sizes. So how can we find out this from this data? See, it is given that the size of aggregates vary linearly. Okay, so there is a linear variation. Okay, it is given that the size of aggregate vary very linear. So if we just interpolate the data, we can get the D60, D10, and D30 sizes. Okay. So let us find out. So for D60, you can write it like this. You are just interpolating it linearly. Okay, nothing else. Just interpolation. So from here, you will get D60 is equal to 3.47. Okay. Again, similarly, we can find out D30, that is 80 minus 7 by so D30 will be so similarly again if you find similarly in the same fashion you can calculate the D10 sizes. Please calculate the D10 size. Okay, yeah, please calculate, interpolate and calculate in the same fashion, exactly the same way. Please find out the D10 size. Tell me what it is coming. Will hardly take 1 minute. Okay, please find out. So equals really 80 minus 7 by 4.75 minus 0.075 equal to 80 minus 30, sorry, So it will be 10, right? 80 minus 10 by 4.75 minus D10. So if you calculate like this, our D10 comes out to be 0.267 mm. Okay. So you got the values. Now similarly, you can find our CU value. CU is nothing but D60 by D10. It will come out as 12.99. Okay. And our CC comes out to be D30 square by D10 into D60. It will come out as 2.59. Okay. So you have the value of CU and CC. Now please tell me whether it's poorly graded or well graded.
Well graded, sir, because CU is greater than 6%, CC is greater than less than 3.
Yeah, CC is between 1 and 3 and CV is greater than 6. So it is
6.
well rated. Okay. So
Well
this
graded.
is the, sorry, this is the, so not this. Yeah, this is the correct one. It will be well graded sand and silty sand both. So this is the final answer, SWSM. Okay. I hope this is clear. Now third problem. So again, sieve analysis data is given to us. Okay. So we need to classify the soil and it is given that the total weight of the sample that was used in the sieve analysis is 500 gram. Okay, so sieve sizes are given and weight retained is given, and also the total weight that was used in this sieve analysis that is given. So can anyone tell me what is the main thing that first we need to determine here?
Percentage.
Yeah, percentage what? Percentage of what? Our main target is, yeah, retained also, yes, but final goal is percentage final. Okay, we need to determine percentage final, so that is the main target. So let us write. So we have sieve size, weight retained, percentage weight retained, cumulative weight retained, and percentage final. Okay. So first is 0.6, 0.5, 0.425. So what is the weight retained? It's 200, 250, and 50. Correct. So what is the percentage of weight retained?
40.
Yeah, 40%, right?
40%.
Again, next.
45%.
How 45?
50%.
50. Again.
50%. 10%.
Yeah, 10%. So now cumulative percentage weight retained, please tell me.
40, 90, and 90, 100.
Okay. Done. The percentage final.
60,
Hmm?
10, 60, 10, 0.
Oh, yes, correct. 60, 10, and 0.
0.
Correct. Okay. Now, now you can see that more than 50%, is passing through our 0.6 mm sieve.
Sand.
So the soil will be sand. Okay.
Sand.
More than 60% is passing through 0.6 mm sieve. So it will be, no, see, wait. It will be either sand, or why cannot it be clay? It can be clay also, na, fine also, na, clay or silt also. How are you saying that it can be only sand? Okay, it cannot be gravel. Okay, you eliminated gravel. Okay, how can it can also be sand? If you just look into this data, 60% is finer than 0.6 mm. It can also be your clay, na, clay or silt. Correct. So for that you have to look here or here. See how much is finer than 0.425 mm. 0% is smaller than. So how much will be finer than 75 micron? How much will be finer than 75 micron? Please tell. How much will be finer than 0.075 mm? If 0% is finer than 0.425, how much is finer than 0.075?
0.
0. Obviously 0. That means our soil is 100% sand.
Sand.
Yeah, sand. Now you need to tell if it's sand, if it's poorly graded or well graded. Okay, the sand is confirmed. Okay, now you need to tell poorly graded or well graded. For that, what you need to do again? You need to determine the CU,
CU.
CC, CU, CC. So let us determine the CU. CU is my D60 by D10. So please tell me what is D60?
0.6.
Yeah, correct. And what is D10?
0.5.
0.5, correct. So what is the answer? 1.2. Okay, so
1.2.
So tell me if it is poorly graded or well graded.
Poorly graded. Because
Why?
CU is not less than 6. CU is less than
Yeah,
6.
CU is not greater than 6, right?
Not
CU is
greater.
less than 6. So it will be, the final answer will be poorly graded sand. This is my final answer. Good, correct. So let us go to the next problem. Yeah, problem 4. Okay. So from the sieve analysis data given, classify the soil. Given total weight of sample used in sieve analysis is 100 gram, 1000 gram. Okay, total weight is given. Also, the liquid limit and the plastic limit is given. Okay, the liquid limit is 40% and the plastic limit is 18%. Okay, similarly, what we need to do is, first step is find the percentage finer. Okay,
Final.
yeah. So please tell me. So this is the sieve size 0.4 mm. What is the weight retained? 20 gram.
20 gram.
730 gram.
730 gram.
What is the percentage weight retained? 20 divided by 1000 into 100%.
2%.
2%. And next, again,
730 divided by 1000 into 100.
200.
73%.
73%. Yeah. Now, what is our cumulative retained?
3%.
2%. Sorry, 2%. Na?
2%.
2% and
75.
75%. Correct. A percentage finer?
98%.
98% and
25%.
25%. Correct. Now, please tell me, by looking at this data, what is our soil? What should be the prefix of the soil?
Is in between 5 to.
First tell me if it is sand or fine. Sand, if it's sand or clay or silt. Okay, tell me this. Is it sand, coarse? What?
Fine soil.
How is it fine soil?
Because more than 25% of soil passing through 75 milligram.
What is the condition? Our condition is that if more than 50%, of the soil passes through 75 micron, then our soil is predominantly fine.
Fine.
Okay. So here only 25% is passing, right? So what will be our soil? It will be, please tell. Coarse, right? It will be sand. Correct? Yeah, it will be sand. Because less than 50% is passing through 75 microns. If this, in place of 25, it would have been 51, then it would have been our fine. Okay, but it is less than 50%. It is 25%. So it is sand. So first part is fixed. It is sand. Now tell me, what is the fine fraction here? 25%. Correct. Correct. So 25% is more than 12%. Our 25% is more than 12%. Okay, so how should be our nomenclature? What will be the second part?
The plastic limit and
Suffix will be C or M.
Exactly, correct. It will be C or M,
clear.
clay or silt. Now you need to determine what will be our suffix. Okay, for that purpose, other information are given to us. It is my liquid limit and the plastic limit.
Plastic.
Okay, so liquid limit is 40% and plastic limit is 80%. Tell me the plasticity index. What will be the plasticity index? What will be the plasticity index? Plasticity index is nothing but what? Liquid limit
2.22.
minus plastic limit.
Sorry.
40 minus 18, right? It is 22%.
22%.
Correct. This is my plasticity index. Now,
Yes.
now come to your A line. Come to your A line. So what is the equation of A line? Plasticity index equal to 0.73 liquid limit minus 20. Okay, please put liquid limit equal to 40% here and find out what is the value. I will also calculate. Please find out.
14.6.
Yeah, 14.6%. Okay. Our plasticity index is how much? 22%. Okay. Our plasticity index is more than this A line, what you calculated from A line, more than 14.6%. Isn't it? This means our point is above the A line. Correct.
Correct.
This 14.6 is on the A line. Our value is 22%. It's above the A line.
Above the line.
Correct. So if it's above the A line, so one thing you found out that it will be above the line. Again, one thing you check that our plasticity index is greater than 7. Is greater than 7. So this region is not coming. Okay. Plasticity index greater than 7. Correct. So it's above the A line and also it's not falling in this region. So what will be our soil? Please tell me.
Clay.
Correct. Clay. So what will be the final nomenclature of the soil?
SC.
SC
Sandy
means
clay. Sandy
no,
clay.
clay sand,
Clay sand.
not
Clay
sandy.
sand.
Yeah, clay sand. Correct. Okay, so this was basically the course part. Okay, so mostly we're dealing with the course classification. Okay, from this problem onwards, we will be moving to the fine grain classification of fine grain. So, okay, so classify a clay sample. Okay, it's given in the question that our soil is a clay soil. Okay, so our soil is a clay soil. Correct. So first, already from the question, in the question only they have told you that the first part, the prefix will be C. Correct. Also, they have given the liquid limit and the plasticity index. Okay. Okay. Now you have to tell me what will be. It will be like C M C sorry C L C I or C H. So please find out and tell me. You have a liquid limit and you have a plasticity index, both.
CC. It's coming under the clay.
No, clay, yeah, clay is final. We already know from the question. Also, you can check that plasticity index is 28%, right? Now, from the A line equation, if we find out the plasticity index, it will be how much? 0.73, 40 minus 20. It's how much?
14 point something.
14.6. Okay, this is greater than 14.6. So it is definitely this clay. Now you tell me, give me the suffix. It's CL, CI, or CH. Tell me this.
CL. Yeah, in between, below that 35%.
How
If,
below 35? Liquid limit. See, you have to check the liquid limit. What is our liquid limit here?
40.
Then
30, 35 between 50 equal
35 yeah, so it
intermediate.
will be
Intermediate.
intermediate CI. So this is our answer. It will be CI, intermediate clay. Okay. So go stepwise, very slowly, one by one. So like that, everything will be clear. Okay. No need to hurry. Okay. Do aram se, like don't hurry. Be relaxed. Go stepwise to one by one. So your answer will be 100% correct. Okay. There is no chance of mistake here. Okay, just a second. Okay. Now, now let us go to the next problem. The next problem is classify a soil sample if it has a liquid limit of 40%. Okay, liquid limit is given 40%. The plastic limit is 30%. So you have the liquid limit and you have the plastic limit. Okay, you have the liquid limit and you have the plastic limit. The percentage passing through 4.75 mm is 65%, and that through 0.075 mm is 58%. Okay, this is also given to you. Now, please tell me what kind of soil it is. It is coarse soil, it is fine soil.
Fine soil.
Why fine soil?
Because of 50% soil passing through 75 micron.
Yes, more than 50% is passing through 75 microns. See if our soil is a fine soil.
Fine soil.
Done. So it will be either clay or silt
Silt.
or organic. Yeah, mostly it will be clay or silt. Okay, C or M. Organic you don't know. Organic, if you don't look in at the soil, you cannot say if it's organic or not. Okay, so it will be clay or silt. You are correct. Okay. Now it will be clay or silt, right? Now from the liquid limit and plastic limit, please tell me what is the plasticity index?
It may be a
What is the
intermediate clay.
no two step by okay, you are saying it's intermediate clay you are saying. Okay, let us see. You are saying it's intermediate clay. Okay, let us see if it's correct or wrong. So what is my plasticity index? Please tell me.
10.
Yeah, 40 minus 30
equal 10.
10%. Okay, now find out plasticity index from the A line. 0.73 liquid limit minus 20. What is it? 14.6%. Not percent actually. Whatever. So 14.6% is our plasticity index. Now tell me if it's clay or silt.
Silt.
Exactly. Why is it silt? Because it is plotting. It is plotting below our A line. Okay, it will be plotting in this region. Okay, so it is silt. So the first prefix will be M.
Sorry.
Okay, now check one more thing, that if any dual classification is possible, like if this hash region, we are coming into this hash region, no, right? Because our plasticity index is greater than 7, so our hash region is out of bounds. Okay, it is out of bounds from us. Okay, so you don't need to bother about it. So no dual classification. So it is M, right? Our soil is silt. Now you need to tell me if it is low, intermediate, or high, highly plastic. Please tell me.
Intermediate.
Yeah, why intermediate?
40%.
Why 40%? It is between, liquid limit is between 35 and 50%. Yeah, that's why it is MI. Okay, intermediate plastic silt. Okay, so it might be OI also, correct? From this chart, if you see, it might be OI also. OI you cannot say, it will be either MI or it will be OI. Okay, it can also be OI, it can be MI. Okay, so these are the two probable outcomes. So it is not CI. It is silt, intermediate plastic silt, or intermediate plastic organic clay. Okay. Okay. Okay, so now let us look at this question. Classify a soil sample if it has a liquid limit of 10%. Okay, a liquid limit is 40%,
40.
and the plasticity index is 10%. The liquid limit of overnight sample is also given as 25%. Okay, the percentage passing through 0.075 mm is 62%. Okay, this is the data that is given to you. So again, tell me,
Fine clear.
yeah, fine grain, right? Why fine grain?
More than
than
50%
50%.
particle passing through center.
Okay, 62% is passing, which is your more than
50%.
yeah, more than 50 percentage. So it is your fine grain soil.
Fine grain, sir.
Correct. Now you have the liquid limit and you have the plastic limit, plasticity index. Okay, so again, please find out the plasticity index of the, see, already here plasticity index is given, it is 10%, right?
10%.
Now what is the plasticity index of our A line?
14. 0.3
Yeah,
L minus
how
20.
much? How much?
14.6.
Yeah, again 14.6%. So our plasticity index is less than 14.6.
Less.
So it will plot below the A line, right? It will plot in this part. Correct? 14.6% is you get the equation of this line, and our plasticity index given is 10%. So it's below our soil is below the A line. So the soil is nothing but either sealed or
Organic.
organic. Okay, either M or O.
Oh.
Okay. Okay, it is either M or O. Now tell me one more thing. Tell me what will be the suffix?
I.
It will be how much? I. Because
35 to 50.
yeah, again our liquid limit lies
The liquid
between
limit is
35% to 50%. So it will be I. Okay. So it will be MI or OI.
OI.
Correct. Now see, I have given here one note. Okay. So if the liquid limit of overnight sample, okay, if the liquid limit of overnight sample is less than 3/4 of in situ soil sample, means the liquid limit of overnight sample is less than 3/4 of the liquid limit of in situ soil sample. Means just to take out from the uh, like from the site the soil and you do liquid limit test in it. Okay, or else you take out from the site, then you dry the soil, and after drying you then you do the liquid limit test. So both of them, if they give different results, and the liquid limit of overnight sample is less than overnight sample's liquid limit is less than 3/4 of the liquid limit of in situ soil sample. Okay, okay, in situ soil sample, then the soil is organic, else it is inorganic. Okay, so what is the liquid limit of in situ soil?
Sir, what is
Yeah,
the meaning of liquid limit of oven dry samples?
oven dry sample, I think here they mean that like when generally see if you just take out the soil from the ground, okay, from the site, from the ground you just take the soil, you sieve it directly, you sieve it, whatever, you don't dry it. Okay, you just take the soil from the ground and then you just do the sieve analysis, and then after the sieve analysis you find out the liquid limit. Okay, this way you get one liquid limit. And another option is that you take out the soil, then you dry it in the oven, you put in inside the oven for 2-3 days. Okay, at 100 degrees Celsius, 90 to 100 degrees Celsius, you put it in the oven for 2 to 3 days, and then you conduct the liquid limit test on it. Okay, so like this if you do, that is the liquid limit of oven dried soils. Okay, so if the liquid limit of the oven dried if the liquid limit of overnight sample is less than 3/4 of the liquid limit of the in situ soil sample, then it is organic, else it's organic. So now what is the liquid limit of the in situ soil sample?
25%.
No, 40%. In situ. In situ means directly
40%.
40%. Okay. And what is the liquid limit of our overnight sample? It is 25%. Okay. Okay. Now what is 3/4 of 40%? What is 3/4 of 40%?
30%.
30%. So the overnight sample, the liquid limit of overnight sample, it less than 3/4 of the liquid limit of our soil. Okay. 25% is less than 30%. So we can say that our soil is OI. That is our intermediate plastic organic clay. Okay. Intermediate plastic organic clay, organic soil, whatever. Okay. So it is organic. So this is not actually the like that strict test of organic soil. Generally, the most distinguishing parameter for organic soil is the color. Okay, the color and the smell. The color and the smell is the main distinguishing characteristic. Okay. Other than that, this is one more parameter which should be satisfied for organic soils. Okay. Say this portion is not given. Okay, so this portion is not given, so you can easily confidently write your soil as Mi or Oi. Okay. Now let us go to the next problem. So in this problem we need to classify a soil sample if it has a liquid limit of 35% and plastic limit of 20%. Okay, the liquid limit is given, the plastic limit is given, the percentage passing through 0.075 mm CV is 20%, and the percentage retained on 0.475 mm CV is 60%. Okay, so please tell me what kind of soil it is, coarse or fine?
Coarse soil, sir. Coarse soil, because 60% of soil is retained and 4.75 micron.
Correct. So first we said that our soil is coarse soil. Okay, coarse soil. Okay, now what kind of coarse soil? Sand or gravel?
Gravel, sir.
Why gravel?
The grain size is about 2 mm.
No, it is gravel because more than 55% of the soil quantity is greater than 4.75 mm. Okay.
4.75.
If the size of the grain is smaller than 4.75 mm, between 4.75 mm and 75 micron, then it is sand. If the size is greater than 4.75 mm, from 80 mm to 4.75 mm, it is gravel.
Gravel.
Okay, so here 60% is retained on 4.75 mm, right? So our soil is gravel.
Gravel.
Correct?
Yes.
So we already, out of the two parts, we already know the prefix, that is G.
G.
Now we have to find out the suffix. Okay, now tell me what will be the suffix, like in what category the suffix will come. It will be either this or this. One or two. Tell me which one will be, one or two. What will be the suffix? W or P or C or M? Why two?
In the question, liquid limit and plastic limits are given.
No, that is one. If it's just given to confuse you, what will you do? Okay, it might be the thing. And just simply for small quantity also, we can find out liquid limit, plastic limit, and we can give. Okay, that is one, you are correct. But the main thing is that you can see here that the percentage passing through 75 micron is 20%. Correct.
More than 12%.
Yes, exactly. Correct. It is 20%. This is more than 12%. Okay, so this will be C or M. Correct. Now please tell me what will it be? C, it will be either C or M. Need to tell it either it is clayey gravel or silty gravel.
So it may be the soils on the A line.
Soil is under,
A line.
means below a line you are saying. You are saying here.
So it's above a line actually.
Okay.
Because
So
a
it's
line
under the A line.
Okay, let us see. Let us see. Let us find, first of all, find out the plasticity index. What is the plasticity index? Liquid
LL
limit
minus
minus plastic.
Liquid minus plastic.
35 minus
20.
20.
15%.
That is 15.
15%.
15%.
35 minus 20, 15%, right?
15.
15%. Now let us find out it from our this A line equation. 0.73,
Minus 35 minus 20.
35 minus 20. How much?
10.95.
So it's plotting above a line, right?
Above A line.
This is greater. 15% is greater than 10.95, right? So if it plots, one second.
So clay.
Yeah. So it will be clay. It will be GC. Correct. So do slowly. First of all, find out the plasticity index of your soil. Then find out the plasticity index of the A line. Then match those two. Also, one more thing you always keep in mind: check that if it is not between 4 and 7%. That thing also you need to see. So our soil is clayey gravel. Okay. Now let us come to the next problem. So the next problem, we need to classify, similarly we need to classify soil like all the previous problems. The percentage passing through 4.75 mm sieve is 98.5%, and percentage passing through 0.075 mm, that is 75 micron sieve, is 35%. Okay. So okay, and also some other parameters are given to you. D60 size is given, D30 is given, the D10 size is given, the liquid limit is given, also the plastic limit is given. Everything is given to you. You need to classify the soil. So tell me first whether the soil is
Sand.
fine
Sand
or
soil.
why sand?
Passing
Because
90.
less than 50% of not passing through the 75 micron. Passing this only 35% only passing through
Passing through 75 micron. Correct. Only 35%, less than 50%, right? So
less
it
than
is a
50%.
coarse soil. Coarse soil, and the why it is sand? It is sand because 4.75 mm sieve passing through 4.75 mm sieve is 98.5%. Okay, so that is sand. That is not gravel, because most of the soil is passing through 4.75 mm. So our soil is sand.
Sand.
Correct. Now you need to find out the second part. Now tell me, what is the this one? What will be the second part? What should be the second part?
More than 12%.
More than 12%. So it will be
Clay or silt.
correct. So passing through 75 mm, 75 micron sieve is more than 12%. Here it is 35%. So it will be either it will be clay C, or it will be either silt M.
Yes.
Okay. Now one more question I want to ask. What is this D10 size called?
10% finer soil. 40.
No. Yeah, there is some name of this soil, right?
Effective size.
Effective size.
Correct. It is called
Effective
D10
size.
size is nothing but the effective
Size.
Okay. Effective size. So the first prefix we already found out. Now we have to find out the suffix. So what we need to do? Suffix will be either clay or silt. Correct. So let us find out the plasticity index. What is the plasticity index of our soil?
3.
Yeah, it is 22 minus 19 is equal to 3%. Okay. 22 minus 3%, it will be okay. Now let us see what is the this one, A line. Plasticity index 3% means what? It is very low plastic soil, right? It is very, very low plastic soil. Plasticity is very low, extremely low.
Suitable for road.
Silt, sir.
Huh?
Silt.
Silt. Why silt?
The below the A line, silt can no plasticity.
Yeah. So what is my what is the value from this? How many?
Fine.
This one. See, if we do from here, I think we cannot get, because yeah, this is only valid for, I think, our plasticity. How much is our plasticity index? Is 3%, right?
Percent.
Mm. So if you go through this, we cannot. Yeah, you are right. 3% is our plasticity index. 3% is a plasticity. If you see this graph, where it will fall, our liquid limit is how much? 22%, means it's here. Okay. And our it is 3%. So it will be here, somewhere here, right? Right. So it is very low plastic. The plasticity is very low. If the plasticity is very low, then we can say that
Yes,
our
silt.
soil is silt. Yes.
Silt.
Okay. So just by finding out the plasticity index, you can directly say that it is silt, because the plasticity index is
Silt.
less than 4%.
Less than.
Understood? See, if it is less than 4%, do not write the equation, find out like this. See, if you find out the equation of the plasticity index from the equation of A line, it is coming out to be 1.46, right? So 3% is greater than 1.46. So I will tell that it is clay. It is above the A line, right? If you look from here, so this problem is little critical. Okay, if someone directly calculates like this, okay, say if he finds out the plasticity index, he finds out it's at 3%. Okay, then he find out the plasticity index from the A line equation. Okay, it comes out as 1.46. Correct. Then he will tell that 3% is greater than 1.46. It's above the A line, so it's obviously it will be this one. Probably obviously it will be clay. But no, if you see this, if your plasticity chart, this equation is only valid in this region. Okay, from this region, in this region. Below this, our plasticity index 3%. So it's written here CMML. So it is silt. 100% it is silt. Understood? That's why we are saying that it is silt. Okay. Let me repeat this one once. See, if you look into the A line, the equation of the A line is this one. Okay. So what you may do is that you got this question. Okay, fine. Sand you determined first. Then you find out, you wrote your plasticity index 22 minus 19 is equal to 3%, done. Then what you do is, you, like previously what we did was, in all the problems we found out the plasticity index from the A line, right? Like this. And then we said that if it is, as it is greater than this, it is above the A line. So our soil is clay. Correct. But if we follow the same format in this problem, see, what we calculated the plasticity index from the A line, 0.73, 22 minus 20, it comes out to be 1.46. Okay. So our one is 3%. 3% is greater than 1.46. So it should be above A line. So it is
Well,
clay. But actually, is it the case? No. See, this equation you can only use in this part, okay, in this part, above this line. Below this line, below between 4 to 7, below, like in this part, if our precision is 3%, it is below 4%, so it is 100%, it is written here C. It is written here M. So it will be 100% C. You cannot say from this equation. Okay, so this is very important problem. Many people do mistake in this. Only about, if it above 7%, then you use this. Okay.
If it comes between 4 to 7,
4
then
and 7, then it will be SCSM like this.
Okay, thank you, sir.
Okay. So this is very important. Okay. So we have like completed all the problems from this topic. So one question last week, this was asked during the discussion, that base exchange capacity determination. So okay, so this problem is there, as someone so one of you have told that this problem is there in Gopal Ranjan book. So yes, so this problem is there in Gopal Ranjan book. So I will just solve it again for the convenience. And yeah, I also saw that in the discussion, someone had written that it should be none of this. So the TA, your course TA is.
Sir, I have written, sir.
Yeah, actually I saw that. So your course TA has replied to you, I think. The course TA is Mr. Gobindo Das, okay? So he's also research scholar at IIT Kanpur. So he's your course TA. So he's handling all the assignments and all, setting up the problems, grading of the assignments. So everything he's handling. So I think he has replied to you that he will take care of it. Okay. So I think I saw in the discussion. So actually that should be none of these, none of the above. Okay. But in the answer key, it's even, I think, B or C. I forgot. I don't remember. So let us solve this problem and end today's discussion. So our question is, determine the base exchange capacity. Determine the base exchange capacity of a clay if 100 gram of dry clay soil absorbs 80 milligram of calcium. Okay, we need to determine the base exchange capacity. Find the quantity of hydrogen that can be absorbed by 5 cubic meter of this clay. The dry unit weight of this clay is 1500 kg per meter cube. Okay, so we first need to determine the base exchange capacity. So what is base exchange capacity? If anyone can say, what is base exchange capacity? What is the definition of base exchange capacity? So base exchange capacity is nothing but the ability of clay particles to absorb ions on its surface or edges. Okay, so it is nothing but the capacity to accommodate, that is on the surface to absorb. So it is nothing but surface chemistry problem, right? So we have learned in class 11 and 12 surface chemistry. There was a chapter, so it is nothing but surface chemistry problem. Adsorption, okay, not absorb, it's adsorb the surface. What is the ability of clay particles? What is the ability of a clay particle to absorb, okay, certain ions on its surface or edges? Edge, it might be face or edge, okay, anything. Okay, this is the definition of base exchange capacity. Okay, I will just write it down. Ability of clay particles to absorb ions on its surface or edges. This is my base exchange capacity. Okay. Now let us solve this problem. So we need to see. It is given that 100 gram of dry clay soil absorbs 80 milligram of calcium. Okay. So what is 1 milliequivalent? 1 milliequivalent means 1 milligram of H plus. Okay. So H is monopolar. Okay. One ion, H plus. And what is calcium? My calcium is 2 plus, right? If my calcium is 2 plus, and what is the atomic weight of calcium? Atomic weight of calcium is 80, right? Sorry, it is not 80,
40.
it is 40. Yeah, 40. So if 1 milliequivalent is equivalent to 1 milligram of H plus, then it will be equivalent to how much? 40 divided by 20, 20 milligram of Ca2 plus, that is 20 milligram of Ca2 plus. Okay, in milliequivalent terms, we are representing. Milliequivalent is nothing but this one. In terms of hydrogen ion, one weight of hydrogen ion representing everything. Okay. Okay, one equivalent is equivalent in terms of hydrogen, it's 1 milligram. In terms of Ca2 plus, it's 20 milligram. Okay, that is 1 milliequivalent. Okay. Now in the question it is given 80 milligram of calcium is adsorbed in 100 gram of clay. Okay, so 100 gram of clay adsorbs 80 milligram of calcium. Okay, right? So what is my base exchange capacity? Means how much can my 100 gram of clay adsorb? So it is nothing but 80 by 20 milli equivalent per 100 gram of clay. That is 4 milli equivalent per 100 gram of clay. So since 100 gram of clay absorbs 80 milligram of calcium, the base exchange capacity of the clay is nothing but 80 by 20. That is 4 milli equivalent per 100 gram of clay. Okay. So it was given to us a 100 gram clay adsorbs 80 milli. What we are doing is we are nothing but we are representing this. See, this 100 gram, it's given that it in terms of milligram of Ca2 plus, right? So what we are doing is we are just representing this milligram in terms of milli equivalent. Okay. Okay, milli equivalent. Why you are representing in terms of milli equivalent? If we represent in terms of milli equivalent, 1 milli equivalent is 1 milligram of hydrogen. From there, we can find out the quantity of hydrogen. Right. So nothing, just we are doing it is that this Ca2 plus, see, 100 gram of dry clay soil adsorbs 80 milligram of calcium. This is the base exchange capacity. Okay. This base exchange capacity, we are just representing in terms of milli equivalent. Okay. So before we are writing 100 gram of clay adsorbs 80 milligram of Ca2 plus. Now we are writing 100 gram of clay adsorbs 4 milli equivalent of ions. Correct? Now it's given that 5 cubic meter of this clay, 5 adsorb 4 milligram of hydrogen. Okay. So 100 gram, sorry. Yeah. So 100 gram of clay can adsorb 4 milligram of H. So you found out here that 100 gram of clay can adsorb 4 milli equivalent. So 4 milli equivalent means 4 milligram of hydrogen. Correct? 4 milli equivalent means 4 milligram of hydrogen. So 100 gram of clay can adsorb 4 milligram of hydrogen. So how much can 1 gram absorb? 1 gram can absorb 4 by 100. Okay. So this 4 by 100, uh, see, 100 is in milligram, right? So if we convert it to kg, what will it be? It will be into 10 to the power minus 6. Right? It will be 10 to the power minus 6. And this, where is that? This gram, this 1 gram, if you want to convert it to kg, it will be how much? 10 to the power minus 3. Okay. Now how much? Our 75. So this one finally becomes 1 kg. Okay. By this. So 7,500 kg of clay can absorb 4 into 10 to the power minus 6 by 100 into 10 to the power minus 3 into 10,500. Okay. So which is nothing but 0.3 kg of hydrogen. So the 5 cubic meter of our clay can absorb 0.3 kg of hydrogen. So by this, so say you have two clay. Okay, you encountered two clays. One clay can absorb see, one clay 7,500 kg of one clay can absorb 0.3 kg of hydrogen, and 7,500 kg of other clay can absorb 1 kg of hydrogen. So by
It
looking,
shall be, sorry to interrupt. It shall be 1500, right?
which one?
It shall be for 4 into 10 to the raise minus 6 into 1500. We are
Why
working for 50.
7,500?
That
Now
is
our question,
density. Density
density is
into
1500, na?
Okay, okay. Yeah.
So then 75, 1500, we are multiplying with this 5 cubic meter. Okay.
Okay, okay.
So this gives my 7,500 kgs. Okay. So say you have two soils. Once for one soil, you know that for 7,500 kg of my clay, 0.3 kg of each can get adsorbed. And for other, you can say that you have another clay for each, you know that for 7,500 kg of your clay, 1 kg of hydrogen can get absorbed. So by looking at these numbers, you can directly say that my second clay is more active. Okay, so it has the capacity of more adsorption. Means it's more reactive to its environment. It's more reactive in its aqueous solution. It's more active. Okay, so that's the thing. I hope this is clear. So in the assignment, exactly same problem was given. I think just the values were changed. So I guess that this is clear too. Okay. So if there is any more doubt, you can ask me. And I hope the main, see, this problem which we discuss now, this base exchange capacity, these are not important. The most important thing is soil classification. This is required every time, even like everywhere in every interviews for everything. Like first question they will ask soil classification, like basic question. One of the basic questions they ask is from soil classification. So this is very, very important topic. So I hope this soil classification topic is clear to everyone. And if there is any doubt, you may ask anytime. Okay.
Yes.
So yeah.
Today was more variety on classification.
Yeah. Because the
What
chapter.
happened? Sorry,
uh,
what happened, Ashish? This assignment for this week we submitted last week, right?
Yeah.
And we are working, we are getting more
Yeah.
variety and more
Understand.
understanding. Our
Mm-hmm.
understanding gets clear later.
Yeah, I understand.
So
Actually, I understand the problem because I think they should have given the assignment. I don't know. It's not in our control. You are correct. That only after the discussion, either see in Sunday also one discussion is there, right? So either in any either is one discussion should go, then only you should be allowed to give the assignment problems. Submit it. Then yes, I understand the problem because see your dead now. I think you need to submit your assignment 3 tomorrow, maybe.
right.
But the discussion will be only held in next week. I understand the problem. So that is I think some this logistic issue from their NPTEL side, maybe. I am not sure because we are just
Main problem will be scoring will be less in
yeah,
assignment.
I understand. Yeah, understand. I understand. You can do one thing just in the discussion group. You do one thing. Everyone of you just write there that it will be helpful if like this is held from like the discuss. Like you can do one more thing, but it will be better that you ask the course TA also to like if when you go through the problems, when you go to the lecture after that, if you have any doubt, you can also ask the course TA about the problem because see, I don't have any control. Whatever time and date has been given to us, so we are taking this, right? So I understand the problem. You can do one thing. You can just write in the course group, the discussion group, that it will be better if this is the assignment date is like adjusted with the discussion date. So this thing you can write. Then I think I will also, if possible, I will speak with course T or someone else in detail. Actually, we don't have contact. Once the beginning of the session, like they have given us all the dates and times, so we need to follow that schedule. But your problem is genuine. I understand the problem. It is actually very correct. Because if tomorrow would have been the submission for this assignment 2, it would have been better. Right. So I understand the problem. But what to do? We have to follow whatever has been given to us. Understand? Okay. Then.
Thank you, sir.
And
Very
also,
nice.
yeah. You're welcome.
Thank you, sir. It was
Yeah.
an excellent lecture. Yeah.
Thank you. If you have any doubt, okay, you have my email ID. Okay, you can email me anytime. That is also you can do. And one more thing is, do we have the link of the YouTube channel? Okay, there I will upload everything. If you want to see the problems again, okay, you can see the problems again also. Like see these videos again. Do you have the link?
Yes, sir.
We got yesterday deposited. So in that link, there are
One Google
previous
Sheet, I
also.
think, was there.
Right.
Yeah. So that will the previous videos also. This one also I will upload today, so you can see anytime. And this presentation also I will upload. Okay. So I hope this is clear. Everything is clear. So next now we will like the topics will be going to get more interesting. Okay. Next we will be studying I think soil compaction. So that is more better than soil. The main topic in this subject is shear strength and all. Okay. This is tough and very like mechanically very strong top. You need to be a little like mechanically strong, like in solid soil, solid mechanics and all to understand. So that is very good topic. The shear strength is the main thing. Okay. So after please study properly. And this, I think, from compaction onwards, like all many, these are also important topics, but these are very basic. So now from compaction onwards, the topics are like more like main in depth, where we'll be going into more depth of like proper soil mechanics. Okay, thank you. I hope it was good, and I hope you liked this presentation and it was beneficial to you.
Yes, yes.
Okay, okay. Thank you. Have a good day.
Thank you, sir. Thank you, sir.